Hello, this is Satya. This is my final project for machine learning for product managers. I will start with the problem statement. The problem statement here is to predict the electrical energy output of a combined cycle power plant, essentially for operational efficiency. So what you're planning to do here is to develop a machine learning model based on environmental factors. They have given us a set of data points, and we are going to use that to train a data model and then figure out a way to predict the energy output. So that's the essentially what you're planning to do. And then the data points that we have are around 9,500 data points from various sensors. These are hourly average ambient environmental readings, and it consists of several input features like temperature, ambient pressure, relative humidity, exhaust vacuum, and the target variable is the net hourly energy output. That's the PE. That's what we are going to try to predict. So I chose regression model, and the reason why I chose regression is because the target variable or the goal is to predict a continuous numerical value. Because it's a continuous numerical value, that is the energy output. Regression is the right model, and not just that, they are not asking us to define the energy output as high, medium, low, classified. So it definitely doesn't fall under the classification. And not just that, the in the real world, they really need to know the exact energy output if they want to maintain the grid stability or to meet future demands. So for them, the exact numbers are required. That's why regression is the right model here. And there are multiple ways to do this. One is AutoML. I chose AutoML primarily because of the ease of use. So because I don't have to choose whether we should use random forest regression or addition tree. AutoML does that automatically. It also takes care of hyperparameter tuning, and the model evaluation was easy. I could quickly do things and iterate it. That's why if you see, this is the regression model that I've chosen on AutoML. Uh, and then how am I going to approach this whole thing? As I just mentioned, we are using regression model. I'm going to, the next step is to prepare the data, then split the data based on test training set and train testing set, and then define the input output target variables. Once those are done, I'll run the model based on two primary performance metrics. One is the MAE and other is RMSE. I'll explain why I chose both, because primarily MAE treats all errors as equal, whereas RMSE penalizes large errors. I don't know if the data has a lot of outliers. So depending upon that, I'll run these two models and figure out which one is the right performance metric. Based on that, I'll pick one of these and then tweak the features, meaning I'll remove the least impactful features to reduce the noise and see if the results are good. If it's good, I will compare them. So basically what we are going to do is, after all these comparisons, we're going to arrive at the best performance metric and the best feature set to arrive at the prediction. So that's the approach. First step is data preparation. So here AutoML naturally gives both the training data set, validation, and test data sets. It splits the data, so I don't have to do anything. I just chose the default. And then I did a quick quality check, and there were no missing data. And then I did a data analysis. If you look at the data analysis, it seems like there are some outliers. These could be errors or natural outliers. So that's why I chose both MAE and RMSE to figure out which is the right model to predict. The first one was I had all the features. I didn't remove anything. RMC as my primary, and I ran the results. The results were pretty amazing, as you can see, right? There were very low errors from all the errors, and the R square was also pretty good, a very strong indicator of a good fit. And then one other thing I observed was that both ambient pressure and relative humidity was less than 10%, so they have least importance. So this is the first model. The second model was all features, but MAE is my primary. This time I changed the primary. The observations were quite different. If you see, MAE was like 85, earlier it was 2, and everything was, all the errors spiked, and the R2 reduced compared to the first model. So considering all this, I am eliminating this as my option. But here too, both RH and EP are the least important features, less than 10%. So those are common. I'm going to take them and see if uh, I can further tune it. So Now that I have two data sets, two things that I can remove. I've created two data sets, one for RH, one that removes both RH and AP. And I retrain the models using RMSE for these two data sets. And when I ran, my results were pretty similar. So this is the model 3 that I was just referring to. Here, if you see again, the errors are spiking and R2 is pretty close. So the increased errors in model 1 compared to the model 1, but removing this feature did not improve the performance. Similarly, for model 4, which I removed both RH and AP, it is very similar to model 3. It is slightly better than model 3, but when you compare these metrics against the model 1 metric, the model 1 metric stands out pretty good, both in terms of managing errors and also the R2. So considering all this, my conclusions are that the optimal model for this is to include all the features, and then RMSE is the highest is the model because it gives the highest accuracy. And there are feature impacts. Even if you remove features, it's not enhancing the model. So therefore, it is recommended to keep all the features. So that's the model 1 is my recommended approach, and that's my final decision. Thanks.